Hi, Robert. Thank you so much for helping my project. Could you say a little bit about yourself?
Sure. So my name is Robert Bullard. I am a current professional master's student of space studies at Rice University. And that's pretty much, oh, actually, I'm also an intern at the National Academy of Sciences, assisting the Space Studies Board in some of their operations. So that's a little bit about me.
Do you by chance know Nathan Stewart?
Yeah, he was. When I visited Rice, I was trying to decide between grad programs, and he was one of the guys that showed me around Rice. He's a really nice guy. I like him.
I just interviewed him yesterday, and I realized he also went through the same master's program that you're talking about.
Oh yeah, yeah. I think he's. I want to say he's a flight controller now.
That's
Does that
right.
sound right?
That's
Yeah,
correct.
yeah.
Yeah. He works on the scheduling of the astronauts' time while they're on the mission.
Okay, cool. I'll probably so. Um, I actually recently accepted a job offer to go work at Barrios Technology, which they're a contracting company that works with NASA at Johnson Space Center. So I'll be working on probably in July or August after graduation, working on some of their stuff that they do with the ISS. So maybe I'll probably run into him actually.
That'd be awesome. And which track did you do? The science, engineering, or managing?
So I chose to do the management track. So what I'm assuming he probably gave a rundown of the program when he was on.
Yes.
Okay. So as people probably heard, you can do it's like management, science, or engineering. I chose management, and I chose it because my background is physics, and so I had a good science technical background. I minored in math and economics, and so I already had the economics interest. I just didn't really have so much the applied side, which was more business and finance. So um, I wanted to get some of the exposure to the basically the MBA classes because I was curious about the non-technical aspects, which was good, and it exposed me to people outside of our little cohort because the program is rather small. It I think when I came in, we had like 6 people doing space studies. The majority of the people were subsurface geoscience because Houston oil makes sense.
So you take classes with the subsurface oil science as well?
We took some. I know we took. There's a master's seminar where everybody takes. It's kind of developing interpersonal skills, business skills that cut across discipline. Um, I'm going to take a GIS class this last semester, so I might end up taking some classes with some subsurface people. But for the most part, most of my classes have been with the space studies group. Like I took some solar system physics classes, orbital mechanics, um, some data science, computer science classes, math, things like that. Um, but if I had to guess, it would probably be the GIS class where I'll run into some other cohorts.
It'd be nice to have a GIS system that shows all the resources on the moon, that we're continuously adding to with each of these missions.
Yeah, yeah. So I don't. Have you ever heard of a guy named Kevin Cannon?
I have not.
Okay, so you should look him up sometime.
Okay.
So when I was an undergraduate, I graduated in the fall of 2018 from North Carolina State University, and I was trying to decide between entering the workforce or going to grad school. And the two grad schools I got into were Rice and the University of Central Florida. And when I went to visit the University of Central Florida, great people, really good program. I just wasn't ready to do a PhD, and I opted for the master's. But when I was there was a guy named Kevin Cannon. I think he was a postdoc at the time. And I believe he's a professor at Colorado School of Mines, and they have a space resources program. And I think he's one of the people who are trying to create some type of resource map of the moon when it comes to ice, in particular, um, I'm not a geologist, but I hear the word stratigraphy thrown around. I guess it means like depth, and is it, water ice that's loosely consolidated, or is it in these big sheets? Is it, kind of mixed in with regolith? I'm not, I know there's remote sensing data on that. And I think what people want to do is, I'm sure that map would be valuable in the future, but I think what NASA and some other people want to do is send a rover. And so they can kind of get some ground truth data to back up some of what the satellites, like the Lunar Reconnaissance Orbiter, has picked up on. So I'm very interested in that. I think that's really cool.
Yeah, I think Astrobotic is going to be sending NASA's Viper rover in a couple of years to the moon to do some core samples or something.
Yeah, I think so. It's got, ooh, if I remember correctly. So Astrobotic has two classes of lander, and I think
Yes.
they're heavy. Their heavier lift lander can take is going to take Viper, and I believe there's a company based in California called Honeybee Robotics that has a coring drill that's planned. I think it's on that one. That's planned to drill down and take some samples, um, and maybe get a little bit more insight with some of the instruments that are on there. So very interesting.
Yeah, I'm considering applying for that master's program, just because it's interest of mine, and I'm just trying to find out some more information about it. I mean, in terms of like the commitment and per week, it's pretty much a full-time program, isn't it?
Yeah, it's full time. I would say, at least that's how I've been doing it. Now I don't know if you could do like a part time and maybe it just takes longer. That's an option. So what I'm doing is it's 3 semesters plus a semester long internship. So if you, what industry, what are you in right now?
Software.
Software? Okay. Well, software is used a ton, so that would be a leg up. Um, yeah, I don't know. That's a good question because most of the people that were doing space studies were not coming from industry experience. I'm trying to think. Actually, okay, there is one student. I haven't met her yet because of the pandemic. I've been doing everything remotely since March. I'm actually in North Carolina right now, so not in Texas until I'll have to move. Um, but I think her name is Melissa Ward. She works at Johnson, I believe, as an orbital debris scientist. And so, if there were anybody you should talk to coming from the work world, it would be her.
Okay.
Yeah, she would probably know. And she sounds like a cool person. I think orbital debris is a very interesting problem. And I do want to meet her hopefully this semester.
Yeah, I'm hoping everybody's back to be doing on-campus work by the fall. Otherwise, there'd be no point in going to Rice as opposed to one of these other online programs.
Yeah, I know. It's so I'm a very I really like to learn in person. Um, so it has been. I will say my internship was supposed to be in person. I was supposed to be um, a systems engineer at Barrios at Johnson, but everything got moved online, so that was kind of a bummer. And then I was supposed to go to DC for this National Academies internship, and that got moved online. So it was kind of an unfortunate thing. But the work is still interesting, so that's good. It's just, and I obviously I'm in a fortunate position where I can work from a computer, um, and I'm very lucky to be able to say that. And I'm very lucky that they didn't cancel the internships completely. So, but it is tough, and I hope we do get back to the point where we can meet face to face. Partly because I think so many of the soft connections are important when coming up with ideas and solving problems. It's kind of hard to do it when everything is scheduled around when can you sit down at a computer, and you don't get the body language as much, even with video. So I'll be very happy when we go back to some semblance of normal. Yeah.
Yeah, indeed. And I'm just tired of staring at screens. My whole purpose in starting this project, ironically, was because I was working from home and I wanted to force myself to interact with people on a daily basis. So the fact that I like had to go to Zoom is like kind of
Kind of
that's
kicking the pants.
exactly a step in the wrong direction.
Yeah, I've thought about getting some blue light glasses. Have you ever used those?
I have, yeah.
Do they work?
Um, it was really trendy for a while. My oldest son's been studying like sleep and longevity and that type of thing.
Hmm.
And he was really big into like blue light glasses and, trying to get the optimal sleep and stuff. And so he was getting everybody hooked up with blue light glasses. Um, I'm not sure I took it seriously enough to really say one way or the other, but I would say I don't think he is concerned with blue light glasses anymore, which I think is an indication that, I mean, he took it seriously enough. Is kind of like my thing. So I tend to think it's not an issue.
I think, well, I use a lot of stuff. I like to work at night, so oftentimes I think it messes with my sleep cycle. But if during the day, I'm fine. Yeah.
Do you drink caffeine?
I do. I didn't, but then I started dating a girl who is a coffee addict, and so I've kind of picked up her bad habit of. I'm not quite up to her level, but I do have about 1 cup a day now. So
Yeah, I mean the social connections really difficult. I used to think coffee was awful until I worked with a colleague and he would take coffee breaks and you're just sitting around talking and he's drinking coffee. It's just a matter of time before you start drinking coffee. And same thing happens with smoking, I suppose, too. Um, but I haven't had any coffee, tea. I've had a little chocolate since December 18th. Um, and I can't say it's been like life transformational, which I guess is both good and bad. I mean, like able to continue on without it.
mhm.
But I do miss like the warm liquid and the smell and kind of the the really pick me up. But anyway,
The non-drug parts of coffee are nice. So
exactly. Yeah, the non-coffee coffee.
yeah, and I know even so. I don't remember the name of the company, but back when I was an undergraduate, senior year, I was doing a senior design project, and I didn't like coffee, and so I ordered these. It's just a water bottle, and we had meetings at 8 o'clock in the morning, and I'm not a morning person, so I would have to get up and give these hour-long meetings to our sponsors, and so I just bought basically caffeinated water,
Oh
and I would
wow.
drink those. Yeah, yeah. So
Yeah.
um, can't taste it, but it works. And if you don't like coffee, it's a really good thing.
Wow. We sort of need to be able to take coffee, subtract that out to get I mean, you got decaf, but I mean, there's just a reduction in the caffeine, really, not complete elimination, I
Yeah.
think. So what got you into space? I mean, why did you do the master's program? Did you have an interest before this? I mean, how come you went into business and a minor in math and economics instead of like becoming an aerospace engineer or something like that?
So that's a good question. So originally I wanted to be a physics professor. So in high school, I had a really good physics teacher. His name's Dr. Johnson. We called him Dr. J. And I actually think he also ran an economics club where he basically did like mock stock market trading, and it was just for fun. But he was a very inspiring teacher. He didn't give you the answers outright, and he would make you ask the right questions to figure out what you needed to do to get there. And even though physics was hard, to me, it was the most rewarding class that I took, I think. Um, and so that's what I decided to major in, and I wanted to be kind of like him. So I was like, okay, physics professor, I can do that. And so I started taking classes, and I enjoyed it. And I did a little research. I got involved in a nuclear physics lab doing, how do I say this? I was doing the grunt work, but the overall experiment is really cool. I don't think it's happened yet. It's basically this consortium of like 19 universities and national labs, and what they're trying to do is they're trying to take um, a neutron, which doesn't have charge, and look at it in a way that would tell us if it has an electric dipole moment, which just means that yes, from far away it kind of looks neutral, but maybe it's got this property where it's actually a plus and minus charge separated by a very, 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 very small distance. And that has implications whether or not that measurement is zero or non-zero to different nuclear physics, particle physics theories. And so, I mean, we're talking measuring something like if you blew a neutron up to like the size of Earth, it would be like plus and minus one electron charge separated by the thickness of a piece of paper. I mean, we're talking like a really, really small measurement. And it's been done before, but every time they do it, they knock out possible physical theories, or at least you know, look at the ones where they would have a certain sensitivity for the measurement, and they'd be like, oh, like supersymmetry like doesn't fit or whatever. It might not be supersymmetry, but anyway. So I was doing some work for that, and that's how I got introduced to research. Well, later on, I did a research project with Dr. Karen Daniels at State, and it was basically trying to probe an analog setup for an asteroid. It wasn't the asteroid itself, but it was this like 2D lattice of it was kind of like 1 centimeter diameter hockey pucks made of plastic. But if you put them all in like this, you let them sit in between two glass panels, and then you put certain light polarizing film on either side, and shine a light through it, and then put these things under stress, you get these interesting patterns due to birefringence, which is just bending light in the material. And you can learn something about the dynamics of the system um, by imaging that and studying it. And you can learn something about many body granular forces in a medium like an asteroid. So the point of this was to um, develop protocols that would um, reduce ejecta, and this was sponsored by NASA. I should have said that. Reduce ejecta when digging, probing, anchoring, any surface activity on asteroids. So that was about a year or a year and a half long project, and it was the first thing we did was there was a laboratory, and so we tested it in low gravity by using basically an air hockey table and like tilting it slightly, so you had like very small gravity. Effectively, it would the vector would go down the um the air hockey table, but you still have these air blowing against it, so it's not the best model. And so that was before my time. But when I was a senior and some other engineering students got together and we applied, and we basically built this thing. Actually, I have a you know what? I have a picture of it. Believe it or not. It's kind of hard to see. But I could.
Okay.
Here, yeah. So let's see here. All right. So this I think on my left, it looks like it might be your right, but that little box, there's basically a camera, a computer system, a motor, and a little probe. It's just a little piece of plastic, kind of flexible. And then on the right side is images. There are images from the videos that we took, and you can kind of see if I zoom in here. There are these kind of lightning bolt looking streaks, and those are what we call force chains, because when you impact, basically when you like step on sand, it doesn't evenly distribute through all of the sand. You end up with these like channels that actually hold the stress. And so we took that box and we put it on a Boeing 727. I don't know. Are you familiar with the Zero G Corporation?
I am. I actually went on one of their flights.
Okay, so you know what I'm talking about. Yeah. So we in November of 2018 we took it up and we did some research and got some really good footage in collaboration with University of Central Florida. They were looking at actual regolith, which is a fancy word for space dirt, simulants on the bottom. We kind of built this little 2-level thing. So we were both trying to figure out some stuff. And actually, I believe that the thing I held up is from a paper that I believe has been submitted for publication to, the journal escapes me, but we're waiting to see if that gets published. So that would be cool. I've never had anything published, and I am not first author, but it would still be pretty cool. So long story, but that is how I got interested in space, and doing, research and facilitating research in space. And the reason I chose Rice over getting a PhD in planetary science or physics at UCF was because I didn't have the question in mind, a personal question that I was trying to figure out the answer to, that I could dedicate five or more years of school. But I did want to learn how. I mean, Zero G is a private company, right? So NASA used to have a plane that did this, but they don't have it anymore. So somebody figured out that they could provide this service that, NASA and researchers like, you know, people at my university and other universities, and even I believe the Department of Defense sometimes does research up there. But I thought it was the coolest thing that somebody could run a company that actually provides a service. And I didn't really have any background other than the economics minor. I mean, that's like 5 classes. I'm not an expert. So um, that is what led me to Rice, was the interdisciplinary kind of non deep. I mean, it's definitely like we do STEM classes. Orbital mechanics is hard. Gas dynamics is hard. These things are hard. But I thought the PhD was missing an element, and Rice provided it. And so that's why I went to Rice. And that's what got me interested in space. So
That is awesome. But I I have a question from like your personal perspective. Do you see humanity actually branching off from the Earth and spreading out into the rest of the solar system, or do you think it's mainly, the solar system is something to study, but not really like the next frontier? I mean, what's kind of your view on that?
it's a good question. I think I think humans in space is an important thing. Um, there's a lot of, there's sometimes this. Sorry, somebody just pulled up outside my house. Oh, I think they're just fixing. They're just changing drivers. I'm sorry.
No trouble.
Um, yeah, I think humans in space is important. There's also this, there's these two sides that in science at NASA anyway, robotic and driven, human driven exploration versus robotic science missions. And people often say, well, you can get a lot more science for the money if you go with robots, and you don't have to worry about keeping the humans alive and all that stuff. But I think it's kind of foolish to just focus on one or the other. I think both are equally important. It's just it sometimes the funding is not there to do both. But as far as humans being in space, I think it's important, not necessarily for scientific reasons, although studying the human body in orbit around Earth has been incredibly insightful. Studying plants on the ISS has been incredibly insightful. Materials research, how fluids behave in microgravity, how fires burn in microgravity. It's really important. Um, but outside of the scientific value, I think there's an inspirational value to having humans explore um, space, and even further in the future live in space permanently. I know there's a show called The Expanse. Have you ever seen that?
I have. I've caught up season 5 just recently. I binge watched it this week. So yeah.
Okay, so you're way further than me, but I'm about halfway through season 1, and you've got Martian civilization, you've got Earth, which is governed by the UN, and then you've got the Belters, which are who are on out in the asteroid belt. And it's interesting to see how much politics still plays a role because there are humans, and they're competing over different resources and interests. Um, but I think human space. Like, what was your question? Do I think that humans should settle? The
Um, well, I guess there's two parts of it. One is, do you think humans should expand beyond the Earth? Why don't we
Yes,
stick with that?
yes.
Okay. And what's your time frame for that expansion? Do you think at some point in the future, or do you think earlier the better?
I want to bound it. I don't want to just say some point in the future. So I would say, oh, that's a tough one. Um, hmm. Well, I could definitely see if you had the political will to and the funds, um, having a permanently staffed or crewed lunar base would be cool, and useful for science because I remember listening to this scientist. I think his name's David Kring or Craig. I think it's Craig. Um, Harvard Harvard geologist, now works with the Lunar Planetary Institute.
Oh
And
yes, he actually came and did a talk at Rice. I came to that.
yeah, yeah, he spoke. So we have a seminar my first semester at Rice, and it was every week we would have somebody come in and speak to the class about different what's going on in space exploration. He was one of the people, and he expressed how so much science could be done if we had people on the surface. Um, and I think that could be done in like a 20. I think 2024 is past. I don't think that NASA had the budget from Congress. I think they requested something like, I don't know, $3 billion for lunar landers, and they got 680 million, I want to say, or 1 billion.
I'm gonna
Which,
say 800 million, but the point is they got significantly less than
yeah,
they asked for.
like a third or less. Which, like, if you want to go fast, you know, I think there's a saying that people use. It's like, you either need like money, time. Oh, it's money, time, or something, are all interchangeable.
I
Um,
think it's fast, good, or cheap. Choose any two, something like that.
yeah, like restaurants, right?
Yeah.
But so let's see. So I think 2028 you could probably. I actually think there's a good shot 2028 is a deadline that we hit, if the political winds don't change. Now we're going to have a new administration, so I mean that could change, but I don't see any reason that it should. I don't think spaceflight is a particularly high agenda point for the new administration, given what just happened on Wednesday. We have some other more pressing matters to deal with. Um, but so that's the moon. I think it would be great to have a lunar station. You could probably establish that, technically speaking, 20 years from now. You could probably have it running, and maybe even sooner if it was like an orbital thing, kind of like Gateway. Like the ISS was done pretty. The ISS was built pretty quickly, wasn't it?
Yeah, I think they really started it in say 97, 98. Um, oh, I guess kind of thinking about it, 96, I think the first module went up. And then it was continuously habited starting in like 2000.
Okay, so that's pretty good. I mean, that's Earth orbit, but yeah, it takes money and will to do it, which is the hard part. Collective will is very hard to, and money is hard to get from Congress. Um, and then you've got Elon Musk over in Brownsville, um, and Boca Chica doing all this, uh, Starship stuff, which is amazing. If that actually, I mean, if he really truly, I guess he's the richest person in the world now too. So
He
if he really,
is at the
yeah,
moment with the Tesla bubble. Let's see how long that lasts.
yeah. If he, I mean, if he really, if he keeps up like he's keeping up, I wouldn't be surprised if we get to Mars, you know, 2030s, like mid to late 2030s. I would not be surprised. Um, I will say I think nuclear propulsion would be way helpful to get humans to Mars. Um, Almost necessary. So um, if that gets developed, some nuclear thermal propulsion would be very helpful because the journey is really long, right? And we still don't know psychologically um, if humans can not like go crazy on a year-long trip when you're that far from the planet. Um, so I think yes, we should move out into the solar system. Time frame, given the money and political will, moon, you could get there by 2028, probably into the 2030s. You could have a base if you wanted to. And then Mars, if you really wanted to, mid to late 2030s. If not, if you didn't want to as much, maybe 2040s to 2050 is my guess. But again, I'm a 25-year-old graduate student. So my guess is as good as yours.
Maybe better. Um, yeah, I mean it's funny, whenever you look at what I mean, you talk about money and will. Um, just because you have the money doesn't necessarily mean you have the will, and just because you have the will doesn't necessarily, of course, mean you have the money. But I guess the thing that I keep thinking about is looking at all the billions of dollars that have been spent on, say, the SLS, and the absolutely stunning number of test flights they've done at this
Mm-hmm.
point. And compare that to um, what's being done in Boca Chica. I mean, if SLS is successful, you will literally have a recreation of the Apollo program. There will be absolutely no transformation, no big enabling event in terms of human exploration to the solar system. But
Mm-hmm.
if the Starship is successful, I mean, that will fundamentally transform everything that we do in space. You know, even if they're only able to do half of what they're planning. Uh, can you imagine being able to go from, say, Houston to Shanghai in 30, 40 minutes? I mean, that would be phenomenal.
That would
You know,
be insane. Um, I mean, I can do that with Zoom, right? Or Skype or whatever. But like we said earlier, it's an entirely different thing to be able to physically pick up and be in a different spot and that quickly. Um, yeah, that would be spectacular. And not just people too, right? Like goods, like you could ship incredibly
vaccines.
quickly.
You
Yeah,
could,
vaccines. Oh my God, that's a you already got cryogenic fuel. I mean, you could cool it right next to it, right?
or how
Uh,
about testing kits? That might be cool. Be able to get
yeah,
testing kits any place in the world within 30 minutes.
yeah, that would be very helpful given the current state of the world. Um, yeah, I think the key there is scale, like scale and speed. That's kind of Elon Musk's thing, right? Like, you know, make a bunch of. I mean, he's even doing it with Starlink, which is for people that don't know the SpaceX constellation of satellites that's going in low Earth orbit to provide internet services. I mean, I think they've been approved for 12,000 satellites, and they want to go up to like 30 or 40,000, which is just mind blowing. Um, but if you think about it, it's kind of you know, once you produce that many satellites, you know, one satellite doesn't work and your SpaceX, that's okay. You know, you can just replace it on the next shipment. But if you're somebody like NASA or the European Space Agency and it's a one of a kind, incredibly important weather satellite, for example, or a very important some, you know, some type of scientific satellite that's a one off, you know, you got to protect that with your with your life, because that's a little bit different. But I mean, I haven't actually been down to Boca to look at a launch yet. Have you?
Not to look at a launch. I went there September of 2019, just to take a look. And, at that point, they had only a windshield and I think a tent and the little, kind of like hopper. And now, looking at the pictures you can see online, it's like an entire factory. I mean, they're producing a Starship a month right now. That's the kind of like where they're at.
Dang, that's wild. That's and it's like, yeah, that's it's insane, but it's awesome.
And they're talking about being able to produce two a week, and each of them completely 100% reusable. I mean, like
2 a week.
two a week. Yeah. I mean, Elon Musk about a year ago talked about sending megatons to orbit, cumulatively, not in one craft, but that's the type of scale you need to be thinking about if you're going to build a city on Mars.
Yeah. Also, another technology that's important will be orbital refueling, I think, um, and in situ resource utilization, especially for things like fuel and oxygen and stuff like that. Um, Very important. But
Indeed.
yeah,
Yeah.
so crazy stuff down there. I still want to go down and look at a launch. I actually, so one of my a fellow intern, her sister works on, I think, some of the nose cone stuff for Starship, and I still need to talk to her about what it's like to work on something like that, and see it blow up every month. Uh, so yeah, it's cool.
Yeah. They are just giving them names like serial number 8 was the one that did the test flight, and they put the crater in the exact spot they wanted it, which is awesome. And then SN9 is supposed to be doing a test flight maybe early next week, so it's kind of neat.
Yeah, and on the SLS, I mean, I think SLS is more powerful than Apollo, I think. Um, so like likening it to the Apollo missions, or I guess the Saturn V would be the rocket name. Um, yes and no. It's a little bit more powerful than a Saturn V. But are you saying the architecture where you like shoot one and
Yeah,
just
that
falls
for
into
sure.
the ocean? Yeah.
Exactly. I mean, you essentially spend a decade building a rocket that you use for 2 minutes.
Yeah. That's it better work though. It's got people on it.
Yeah. I mean, a Falcon 9 carries people to the International Space Station.
Yeah. Well, they had to, I mean, they did a lot of cargo missions before that, right? So they were able to fine tune and test it, and then they did the demos. And there's a whole, I'm sure you know this, there's a whole different standard for putting humans on a rocket than like food. But
Yeah, I mean, absolutely. But if your rocket essentially is thrown away at the end of it, you can't really inspect it to the same level of degree that you can a completely reusable rocket. So you're assuming that um, it performed. You're unable to detect certain problems to the same degree that maybe you could with a reusable rocket. When you get the entire craft back and you can inspect, and you're like, oh, you're getting a lot more wear here than we thought, and this isn't holding up as much, and what have you. I mean, so you take a Starship, you use it for cargo launches for, 20, 30, 40 flights, and you inspect it after each flight. I would have a lot more confidence in that than I would, say, an SLS that was built for one-time use. And was it built exactly the same as the other ones? And I mean, it seems
I
to me
guess
the
I guess
safety.
that's I guess that's why they're doing all that testing with SLS, because they don't get a post-mortem like SpaceX can.
Well, I actually feel like it's a more fundamental issue. Um, Boeing management is interested in making their quarterly numbers, and space is kind of cool. Whereas with Elon, he wants to build that city on Mars. Like, I mean, the motivations of the two groups are almost completely different. So with Elon, yeah, let's test it, let's build it, let's make it happen. With Boeing, I think the management there uses that same reasoning, as an excuse to justify additional cost that ultimately end up being profits on the Boeing side. Like, I
Yeah.
think Boeing would be absolutely happy to keep the SLS contract and never fly.
I guess do they at the end of the day, do they make money?
I mean, that's right. And I mean, as opposed to achieving the mission, I mean, there has to be some force to keep them accountable. And there's not that force because, um, the SLS contract, I think, is used as a tool to spread money around to various congressional districts and what have you. And there's like a kind of a political feedback cycle
Well,
there.
I know the guy that I think is head of Senate budget appropriations is from Alabama.
Yes,
Um, yeah,
Shelby.
and yeah, that guy. So I could see how he would, trying to be do what's good for his constituents, as is kind of his job. If you think about it, elected officials are supposed to advocate for their constituents, but of course that can impact, can cause fewer efficiencies on the whole sometimes, which is unfortunate.
Which is bad for his constituents. It's like, is it better to keep a job going in a failing industry that eventually, it's like making water run uphill, or is it better to, put your people in the strongest, most powerful position possible by being the most competitive? I mean, it's
I
like,
guess the second one would be more of a long term thinking, which I think everyone could use more long term thinking uh,
yeah,
today.
yeah, indeed. Um, But I mean, you see this with like drug companies and other places, where it's like trying to maintain the monopoly at all cost, regardless of the fact that, I mean, it's like Microsoft that they had the view that their software would be replaced, obsolete in just a few years. The only difference is would they make it obsolete or would it be their competitors? It's kind of sort of the strategy to think about. Um, well, um, why, what, why do you think we should be going back to the moon?
So let's see, like moon period, or are you saying moon versus Mars?
Oh,
Uh,
why should we send humans to space? I guess is the thing. You were saying that both are important, but
oh, yes.
but but
Um,
I guess, I mean, it makes sense to send humans to space if you already believe that humans should be in space. But for those who don't think that humanity's future is in space, is there any argument that makes sense?
yeah. So there are a few. I think one is it's really inspiring to future generations that would like to or don't even know that they want to work in STEM, for example. So, um, we, and when I say we, I mean like the space industry shares a workforce with the Department of Defense. So for national security workforce reasons, it's a good thing to want kids inspired to explore because some of those skills are also transferable to other positions. That's just one. It's an incredibly good opportunity for international collaboration. I mean, if you look at the space station, we're partners with Russia and the European Space Agency and the Japanese Space Agency, and through that, and there might be some others, but there are definitely others. But I know those are the biggest partnerships. And so, getting people to be able to work on grand projects that actually provide a lot of scientific value, um, it it's good. It's good for diplomacy. It's good for developing intergovernmental relationships. So there's also value in the diplomacy aspect of it. Um, Trying to think of some others. I mean, technology transfer is useful. Um, there are things that were invented in the pursuit of the Apollo program that were useful on Earth. I think some medical technologies for monitoring astronauts ended up being important, inexpensive ways to monitor things like blood pressure, heart, you know, heart monitors, stuff like that. Um, so dollars that get spent on space exploration do end up producing things that are useful to humans in everyday lives. It also produces interesting things like Tang, but that's not as important as things like medical devices, for example. Um, so scientific information, we covered scientific information, new technologies that are useful and transferable to Earth, diplomacy, and education and workforce development. Also, just there's kind of that X factor of the awe of what humans can do. Um, it's a very good way to show technological prowess without it being military, you know, conflict. Because we don't want nobody wants military conflict. That's not good. Um,
It's like technological Olympics.
yeah, essentially. I mean, the Cold War started, you know, kind of started the space race with Sputnik in I think 57, 1957.
Yep, something like that.
Um, yeah, and so you know that it it was a way it was launched on essentially a modified ICBM, and it was less a less violent way to technically compete, essentially. But a lot of good things came out of it. You know, now we cooperate with the Russians on the International Space Station. We might have problems in other areas, but at least we have that. You know, it's kind of like an olive branch, a tension reducer, in a sense.
I, so I'm a big fan of space and space exploration. I like to see more of it, but I like to make sure the foundation's like solid. And so around the scientific discoveries that we made in space,
Hmm.
um, I can't think of any that have really come out of the International Space Station that has been all that really groundbreaking or earth-shattering. Um, it seems it's more of a, kind of a thesis or PhD mill as opposed to, really some type of fundamental research. And I was wondering if you knew of anything that was done in, say, the past 10 or 20 years that you felt was really groundbreaking, but just maybe hasn't gotten the attention that it should.
So on ISS research in particular, um, let me think. ISS specific.
Or just anything space related, but just something in like the last decade or two.
Last decade or two, anything space related.
Anything space related, yeah.
Okay, so um, Hubble. Hubble
Hubble, yep.
gave us a really good view into the universe. Um, I believe. Oh, I don't want to be wrong here, but somebody, I believe there was a Nobel Prize awarded for some work related to dark matter or dark energy, figuring out that the universe was expanding.
Hmm.
Um, I'm rusty on cosmology, but that was a big finding in astrophysics. I would need to go back. I have it in the back of my head. I just don't exactly know what it is. I mean, we understanding the long term impacts on humans. You know, Scott Kelly did a year in space. That's a pretty important study, I think, with the twin study and how it affects humans. Because if you want to, you know, you're talking about living in space, you would need to know if that's even possible. For a while, I mean, who knows? Maybe your blood wouldn't pump to the right areas. We didn't really know until we had astronauts up there and testing it. Um, I'm trying to think. You put me on the spot. Um, really important things. Understanding. Okay, so this is an important one. Understanding how the sun, basically the weather of the sun, which includes ejecting charged particles and like in solar flares or coronal mass ejections, how those things can be predicted, how they can be detected, if because these things can completely, if you had a big enough one, a big enough solar storm, it could wipe out all of the electronics on Earth effectively. There was an older one called the Carrington event, but that was I believe that was in the 1800s. But if that happened today, that would probably cripple our infrastructure, which means, no running electricity, no, which would affect running water and all sorts of things that we kind of take for granted. So that's understanding that is extremely important. The sun's activity, and we have satellites out there that can, detect. I guess I need to explain this. So the sun doesn't always charged particles that come out from the sun don't always go in straight lines. They kind of curve. Um, I think it's called a Parker spiral. Um, I think his name's Eugene Parker. Forgive me if I missed the first name, but he was a solar physicist, solar scientist, and he did a lot of work with solar weather. And so there are these things called Parker spirals, and it's the path that things travel, that charged particles travel coming from the sun. And we can put satellites in place in between us and the sun and kind of catty cornered to us and the sun at these stable places called Lagrange points. And they can sit there and act as like early warning signs for massive particles. Because we can see things with light, because it's light travels at the speed of light. And if it has mass, it's a charged particle has mass, it would be slower. Although probably still moving at relativistic speeds, we could still get some type of early warning. So as far as like a civilizational preservation aspect, that's an important one. Tracking asteroids, satellites, and ground-based telescopes that track large objects that could potentially smash into Earth. It's unlikely that we would see, a humanity-destroying asteroid hit in our lifetime. But even though the probability is relatively low, the damage would be catastrophic. So cataloging those and knowing where those are, they range in size from, that big to, kilometers across. The large ones are pretty easy to see, but as you get smaller, it's kind of hard to track. I think the main method of tracking is looking at reflections from the sun off of the surface, and then you can kind of catch the glint in a telescope and then use math to work out where it would orbit. So, having an early warning system for those would be good. You just have to figure out if you could do something about it, which is a whole nother story. So those aren't necessarily scientific findings at the fundamental level. I guess Hubble kind of is. No, not kind of. Dark energy findings would be very important. Let's see, but I mean, they are important to life on Earth and the persistence of life in general, human life. Also, the first image ever taken of a black hole, that was done, I believe, by ground-based telescopes scattered around the world. Still interesting to physics. Nobody's, up until that point, nobody had seen one. Other space related. So are you talking fundamental science, like fundamental laws of nature, or are you talking like useful applied things? Because there are plenty of those I can think of right now.
Yeah, I think just to kind of maybe narrow down the scope of the question a little bit more is if you had to justify the cost for the International Space the International Space Station based upon the scientific discoveries from it. How would you go about making that argument? Is there some discovery from the International Space Station that would actually justify the $100+ billion we spent on
How
it?
much? How much has been spent on
I
it?
think it's over 100 billion
Over.
cumulatively. Yeah,
Do you
because
know
yeah,
how many years is that stretched over?
I think effectively it's stretched over like, well, um, I would say something like 25 years because you have, and it depends on what you consider as the start of the International Space Station. We had planned space station Freedom at the end
Mhm.
of the Reagan administration, and then with the collapse of you know, the Soviet Union, we started the International Space Station to kind of ensure that those scientists and engineers then go off to rogue states, um,
Mhm.
to take their expertise in building rockets and missiles and go to Iran or North Korea or some terrorist group.
I hear you.
So,
Um,
so I think essentially 25 years. I believe the number is significantly above 100 billion.
okay. Okay. So if I were trying to make the case based on scientific results for the ISS and scientific results alone, um, I'm not as familiar with the scientific output of the ISS as I should be. Um, I probably would have learned a lot more about it if I was in person at Johnson um, for my internship this summer. But I'm trying to think. There are a lot of instruments that are on the ISS that look at the Earth and study things like weather, um, study things like I mean all aspects of weather and climate. There are the human studies, which you know it's pretty valuable to know how the human body reacts to microgravity and living in space. Not only in microgravity, but also it's a higher radiation environment as well. So you can study the effects of those things on humans, but also plants. It was kind of there's a lot of scientific knowledge that is about if you wanted to persist in space for a long time, what would that look like if you wanted to push further? So that's valuable. I think that's very valuable. Um, the weather information is valuable. There are some fundamental physics experiments, I think. The Cold Atom Lab has done some things in inertial sensing and navigation, which is pretty important. Um, what other science has been done up there? I've only been in it for about a year, like related to it for about a year now, and not even full time. So I might not be the best person to make this case because I might not be the best informed. I don't know if that is acceptable of an answer or not.
I mean, I have the same challenge as well. I just feel like we should have kind of a list of like the top 10 things, and they should be something that we could explain to people. This was really worthwhile, but coming with
Mhm.
that list is a little bit elusive. But um, you know, I think maybe it's just a matter of going through all the experiments that have been done on the International Space Station and seeing several things. One is, were they successfully conducted? Was it really necessary to have a space station to perform them? And then what was the impact of the results? Those would be the three things I think I would be looking for. But maybe it's just a matter of
And
systematically going through it.
yeah, maybe there might even be, I'm sure there is. There's got to be some website somewhere that chronicles all of the research that's been done on the ISS. Um, I'll try to find that actually after this call. Um, did you ask Nathan or Nate Stewart about it?
I didn't know.
Okay. Okay. I wonder if he would know.
Yeah,
Um,
I do know of a website where you can look up sort of the experiments and everything, but it has like the titles of the experiments. Like you need to do some digging to actually be able to assess those three things.
And I
Um,
know there is an office at Johnson that is responsible for communicating science and the outcomes of science to the public.
oh,
I
really?
know they run social media, like Twitter, Facebook, Instagram, all that stuff, and do try to put out impacts um, of things that are going on in space, and with particularly the ISS, because it is one of the biggest things NASA does currently. So they're probably the people to look to. And I've met one of them before, but it was over a Zoom call, and I'm blanking on her name, and I feel bad about that. But I'll figure out her name and I'll send it to you, and then she could probably tell you more about the history and the scientific output of the ISS than I ever could. Um, yeah.
So if it was safe and affordable, would you go to space?
Yes.
Like, how safe does it need to be?
Probably as safe as it currently is. I mean, I'd take a Soyuz. They got a pretty good track record. Falcon Crew Dragon has a pretty good track record thus far with humans. So, I mean, if it's good enough for NASA right now, it's probably good enough for me. I'm okay taking the risk. I just think it would be so cool. Now, let me qualify that. I would go to Earth orbit and I would go to the moon. I don't think I would go to Mars. Uh, it's I don't know if I could psychologically take being that far away that long in such a small space. Not to mention the problem with one of the problems, there are many problems to be solved, but one of the problems with going to Mars is there's a long duration journey in a tight space, and it's very hard to shield from high amounts of radiation,
Hmm.
um, especially like heavy ions, like iron ions that come from all over the place. And um, that would have real ramifications for later on in life, increasing cancers and things like that. So with current technology, and that's probably why we haven't sent anybody there, right? Like we're developing that technology. So I would go to the moon probably for a short stay unless there was really good radiation protection. And then I'd hang out in low Earth orbit all day, man. I would be in the ISS like that if you gave me a ticket. Now I don't think I'd pay $1 million because I'm in grad school and I don't have $1 million. But if you've got a spare, actually, even if you got a spare 250,000, you want to loan me, I'll tell you how Virgin Galactic Spaceship 2 is. Would you go?
Um, at the beginning of this, I would say yes in a moment. Uh, but I think it's COVID. For some reason, that's like really like I think dying from COVID, your chances without taking any precautions is probably less than dying from space flight.
Hmm.
Um, I mean, but the difference is, we could take personal protections, whereas how do you really increase the safety of space flight? There's like
You kind of
that
have to
you have to,
rely on other people.
yeah, trust the entire organization. It's really unclear. I mean, wearing a mask is something I could choose to do, or not associating with people closely or going into closed buildings. So I mean, you got that. But I guess the whole safety mentality behind the COVID has sort of made me reevaluate risk in other respects. I was taking flying lessons before COVID started, and I was really working on mastering landings, which I think is important. And you know, I've had moments over the past year where I'm like, do I really want to risk dying in a small plane crash because of the thrill? So I'm still working through that. I would generally say yes. I think I would go to space, but I would say it'd have to be a lot more thoughtful decision than it was before.
Yeah, I think that's entirely reasonable. I think you mentioned you have children. Um,
Yeah.
I do not have children. So I think if I had children, that would very likely change the calculus.
But yeah, I
Uh,
mean, my oldest one is graduating from college. My youngest one's graduating from high school. I mean, they're essentially on their way at this point, right? So I mean, uh, don't want to do anything crazy, but the same token, if something happened to me, uh, their lives would continue pretty okay, I think.
yeah. Well, I mean, yeah, yeah, I guess. But it would be better if you were there. You know what I mean.
Yeah,
Uh,
but I mean, unlike them being like 4 or 5 or 6, and suddenly losing a parent, I mean that
that would
would
be
be
more damaging.
more
Yeah,
damaging. Yeah.
for sure.
So.
But I guess it depends who's taking me to space. I'm being even remotely working for NASA. The culture of safety is incredibly strong, especially given the shuttle accidents. After the shuttle accidents, I've never worked anywhere with more of a cultural emphasis on safety than at NASA, especially when it comes to human spaceflight. Um, and I maybe that wasn't, I don't want to, I'm not disparaging NASA, but maybe in the past some of the cultural there was a cultural problem that led to some accidents. And I in my limited experience, I have not seen anything I would consider reckless. As a matter of fact, could be considered too cautious at times. But I understand why, in the history of why the NASA culture is like that. And so, given their propensity toward safety, I would be very comfortable flying on something that they deem safe. Yeah, but again, everybody's got their own risk profile. So,
Have you heard of Space Hero?
Space Hero? No, I don't think so.
It's a reality TV show contest. It's going to be global. The winner of which goes to the International Space Station for 10 days.
Were they under another name prior?
Um, I don't think so. Um, I mean, they haven't officially launched the contest yet. That happens later this year.
Mhm.
Um, but Axiom Space, who's sending that all private mission later this year, confirmed that they are going to be the ones that will send the winner to the International Space Station. And then I know a few other people involved in the project. So it seems to be the most credible project so far. It'd be interesting to see. I mean, I think a lot of people are going to have their doubts into that very first winner actually goes to the International Space Station. But it's kind of a neat idea. I mean, I've talked to people in Egypt and Pakistan who want to be astronauts, and you know, they have so many more hurdles than you and I have to become an astronaut. I mean, their nation either needs to create a human space program or create some type of relationship with the U.S. or Europe or China or what have you,
Yeah,
or they need to become U.S. citizens or citizens of one of these other countries, I guess. So um,
yeah. So it's called Space Hero.
yeah, they have a website, spacehero.me. Right now, it's just a countdown with a place to sign up for their email list and apply to be in the Space Hero Insiders program, which I did actually. They had like an orientation program last month, and I also talked to one of the co-founders, um, and it seems like it could be really a way to get a broader group of people engaged in space. I mean, this hasn't actually happened to me, but it feels like sort of like people's attitudes, like why should we go to space? What's the point of sending astronauts? And then, well, what about sending you? And then it's like, oh, well, there's an idea. I think I could get around that. I,
Yeah, especially if somebody had a really good platform to the general public, that would be really useful, and good. I know. So there's a think tank at Rice University called the Baker Institute, and they have a program. Um, I don't want to get the name wrong, but it's basically a program where if you're associated with it, you're considered a civic scientist leader, and these civic scientists try to go out into the public. My advisor is one, Dr. David Alexander, and educate people. He's an astronomer, studies a lot of solar physics. That's why I know about the Parker spirals from his class. But he's really good about going out into the general public, people that might not be educated in STEM, because even though I spend a lot of time with people that have education in like engineering or physics or math or astronomy, that's not the general, that's not the experience of everyone. As a matter of fact, it's a minority experience. So I think that's a really good program. And what the Rice Space Institute does, you've been to some of those events, and I think that's a good thing. I hope I'm able to maybe one day be a part of that program. I did some outreach work with the Baker Institute, um, doing some, I wrote things, op-eds concerning space exploration and policy documents to advocate to Congress for more basic research funding. Um, and so things like that should become more ubiquitous, I think, because it's good. People should have a better understanding of where their money's going. It's not just being put on a rocket and shot into the sun, mainly because it's really hard to hit the sun with a rocket. But yeah, I think that would be a good thing. You're on the right track.
Yeah. And it's kind of interesting. I want to do a sometimes survey where you take all the categories the government spend in like a bar chart, and you're like, these are the categories. Now go and label each category and see how people's perceptions based, versus the reality is. Because, one thing Jim Bridenstine likes to say is how small NASA is, but how big people think it is. Like, big
Yeah,
disconnect
we get
between the
like,
two.
say we, but NASA gets like 0.5% of the federal budget each year, which, I mean, the federal budget is gigantic. So NASA gets about 20 billion roughly a year, 25 billion, which sounds like a lot until you realize, the federal budget is much larger than that. Um, but it would be good. I'm sure, I bet the Office of Management and Budget has some of those statistics you're looking for if you're looking to do that. Um, and you're doing a good job of interviewing people from all walks of life and getting their perspective, with this series you're doing. So good job on that. Seriously.
Yeah, it's been a real growth experience. And a lot of people are really thoughtful about space. And, it's like, for most people, it's sort of outside their normal routine, but, you know, given a few facts and questions, they have some interesting responses. So,
So when did you start this project?
December 17th, 2019.
Okay, so you were doing in-person interviews
Yep,
before?
between this December and the middle of March. Um, so.
Okay,
And I
gotcha.
interviewed people on the streets of Houston, at the stores, in Minneapolis, in London, in York, in Edinburgh, just wherever I happen to be, you know.
Dang, cool.
So it's been kind of fun.
Yeah, Edinburgh. So I studied abroad a little bit, and I was doing my stuff in London, and we went up to Edinburgh for a weekend, and it was beautiful. It's a beautiful place. If I had to pick another country to live in, it would probably be Scotland. Um,
I take it you went in summer.
I did, yeah. So it could be a little bit different in the winter.
Yeah. Yeah, I went in February, so I guess that's still kind of winter months. It wasn't bad. It was fine. And I've been reading lately. I'm currently reading through this book, the Worldly Philosophers, and I mean, Adam Smith, Malthus, David Ricardo. I mean, they all I came from Scotland. I mean, there's like, I
Yeah,
mean,
there's a big statue of Adam Smith in Edinburgh.
and I mean, Scotland has had an outsized role in terms of the development of the world, considering its population and where it is and things like that. I mean, like, um, you know, Carnegie, he's from Scotland. Richest industrialist at one time. Uh, and also the person that discovered that we should be using anesthetics, not anesthetics, but actually sterilizing stuff. That's just as important for surgeons to wash their hands before surgery as afterwards,
Yeah.
which actually was
Is
quite a.
that Edward Jenner? Or am I mixing that up with some? That's a dumb thing I just said.
Yeah,
Who-
I'm not sure. I should actually.
Oh no, that's the smallpox vaccination guy. Never mind. Totally different. Okay, sorry. Can you hear me?
I can. I was just trying to think of who it was, but yeah, I went on a medical tour in Scotland, and I don't remember the details, but I remember walking away thinking, wow, a lot of important discoveries were made by people here in Edinburgh.
Yeah, absolutely.
And there's a period of time that I think it's called the Scottish Enlightenment. I think I'll be
Hmm.
reading up on that at some point soon, but. Yeah, so much to learn. Our
Yeah,
ignorance is way bigger than our knowledge.
that is very true. And honestly, that's kind of a good thing because you get to learn something new every day.
I know, but you can never be confident about what you don't know. You're like,
Yeah,
or what's
yeah.
impossible.
Unknown unknowns.
Unknown unknowns. Yeah. I really appreciate your time. I know we went way over probably what you were expecting, but I really
Hey,
appreciate
it's
the
okay.
conversation.
Yeah,
Um,
I'm just really thank you for inviting me to come on here and talk. I've never been on an interview like this before, so I hope I did okay.
yeah.
I don't have any notes. So
Well, neither does the random person at Starbucks. So, the bar is pretty, it's good. Yeah. No, I really appreciate the time and hope we stay in touch and best wishes.
yeah, you too, man. Anytime I mean I come down to Houston probably in July, so hopefully I'll have a vaccine by then and maybe a lot of other people will too and we can hang out in person.
That'd be fantastic. Well, you have a good rest of your day then.
You too. See you
Okay.
later.
Bye-bye.
Bye.